download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about power. Now, power is defined as the rate at which energy is transferred. Okay, now that means that the more energy that is supplied in the shorter amount of time, a quicker period of time, the more power must be supplied. Now, energy, you remember, has a unit of joules, and power is measured in watts. And it is important to note that 1 watt is equal to 1 joule of energy per, or transferred per second. So transferred per second. So 1 watt is equal to 1 joule of energy transferred per second. Now, there are a couple of equations that we need to learn and need to remember when we're talking about power. The first of which is power is equal to energy over time. So P is obviously equal to power, which is the unit is a watt. E is equal to energy, and the unit is joule. And T is equal to time, and the unit is the second. Okay, so power equals energy over time. However, there is an alternative unit for energy. So energy can also be kilowatts per hour. This means that 1 kilowatt is equal to 1,000 watts. So 1,000 watts per hour. Okay, so a kilowatt is 1,000 watts per hour. And therefore we have another equation that can be written like this. Energy is equal to power times time. But energy is in kilowatts per hour. Power is in kilowatts. And time is in hours. The kilowatt per hour is a convenient unit of measure when talking about electrical energy in a household. This is because a household uses a very large number of joules. So 1 kilowatt per hour is equal to 1,000 watts per hour, as we just said. Okay, now there are 3,600 seconds in 1 hour. So therefore 1 kilowatt is equal to 3.6 million joules. Therefore, a kilowatt is a much smaller number to be able to use, and therefore it's a more appropriate unit to measure electrical energy used within a household. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, before we get on to practicing these equations, it's really important that we can convert between a kilowatt and a watt. Okay, now to go from watts to kilowatts, we need to divide by 1,000. And to go from kilowatts to watts, we need to times by 1,000. Okay, so let's do a couple of worked examples. Let's convert 5 kilowatts to watts. Okay, so convert 5 kilowatts to watts. Well, we know we've got it in kilowatts. And to get it to watts, we know we need to times it by 1,000. So 5 times 1,000 is equal to 5,000 watts. So 5 kilowatts is equal to 5,000 watts. Let's do one more. Convert 1,500 watts to kilowatts. Okay, so to go from watts to kilowatts, we have to divide by 1,000. So 1,500 divided by 1,000 equals 1.5 kilowatts. So 1,500 watts is equal to 1.5 kilowatts. So let's go through a worked example for that equation. So calculate the energy transferred from the mains when the TV has 3000 kilowatts of power and is turned on for 3 hours. Okay, so first thing we're going to do is write the correct equation for this. So we've got kilowatts and we've got hours. So we're going to do E, energy, is equal to power times time. And remember in this case that power is obviously our kilowatt, time is hours, and energy is kilowatt per hour. So then what we're going to do is we're going to write down the values we know. So here we've got the power. So power is equal to 3000 kilowatts, and time is equal to 3 hours. So all we have to do then is put these values into our equation. So energy in kilowatts per hour is equal to 3000 times 3. So therefore the energy transferred is equal to 9000 kilowatts per hour. So what we'd now like you to do is have a go at these questions, applying those two formula that we have looked at, and then we'll go through the answer together. So pause the video now. Okay, so let's go through the answers. So for question 1, you should have got energy is equal to 50 kilowatts per hour. In question 2, you should have got that energy is equal to 0.75 kilowatts per hour. In question 3, you should have got power is equal to 833.333 watts. And finally, in question 4, you should have got that power is equal to 2 kilowatts or 2000 watts. So hopefully you've had good practice out using the equation. In this video, we've talked about what we mean by power as the rate of energy transfer, and we've looked at its units in watts, and then we've had a go at practicing the two equations for power. You can now move on to answer any exam questions or go through the quizzes on the topic. And if there's anything you didn't quite understand, please do get into contact with one of our tutors who will happily help.